you to put the date up here at the top and then read this box that says make a conjecture. And I just want you to look at these 2 questions that I have there. Well, 3 questions, I guess. 4 questions. 3 questions. I would like you to look at these 3 questions and then answer them. And I'm not looking for correct answers. I just want you to make a conjecture, make a guess, and then we're going to talk about what would actually happen, and we can see how you did at the end. The next thing I'm going to ask you to do is to recall when we talked about transformations on variables and the effects that those transformations have. And if you don't remember what happens when you add or subtract or multiply and divide numbers by data points, I've listed it there for you. Go ahead and fill that in. The only new thing that I've added is this word locations. And what the word locations means is anything that's considered a location. So for example, a specific data point or saying x equal to a certain number, anytime you add or subtract, that location also changes by that same value, either adding or subtracting, and then same thing for multiplying and dividing. So if you didn't remember this, go ahead and refresh your mind there and put those values there on your paper. We are going to look at Pete's Jeep business and also his sister's business as well in the course of this video, and it gives you the probability distribution. What I would like for you to do, please, is to read example 24 and then find for me the mean and the standard deviation of this random variable. All right, I have my answers there. You can see them on your screen. Don't forget the units is passengers, and you'd want to show a little bit of work there. Okay, let's go on to the next page, page 23. You can see the graph that's there. And actually what I'm going to do, just so we have the values, is I'm going to write u of x and sigma of x here as well. That way I can refer back to it when I'm ready and when I need it. Okay, so I want to say that Pete charges $150 per passenger. And I have a new probability distribution for you. Please find for me the new mean and the new standard deviation of this context here. Alrighty, I have the new values on there. You can check yours against mine. Don't forget the units. In this case, it's dollars. And I do have the distribution of these values over here as well. What I would like for you to do is to talk about the new original graph that we saw on page 22, the new graph that we're going to see on page 23, the dollars. So this is the passenger, and this is the money graph. And go ahead and describe those distributions. There's no outliers, so let's not worry about outliers today. Alrighty, I have my new values in there, and you'll notice that I did put something different over at center. Yes, I found the actual center values, but wouldn't you believe it, that the new center is actually 150 times 3.75. $150 times the old mean of 3.75 gives you your new mean. The same thing happens with spread. It's $150 times your old standard deviation gives you your new standard deviation. Oh, and actually what I haven't done is, well, I should put passengers here. And I should label that these are means. So I would say the mean is, and then standard deviation is. We want to say what those values are. So I should have put that as well. And like I mentioned in class, now that we know how to find the mean and the actual mean and the actual standard deviation, we will want to use those when it comes time to describe our distribution. We'll want to use the actual values for mean and spread as opposed to finding the median and the range, which is what we've done up until now. So let's use the actual mean and the actual standard deviation again, since we have those. So multiplying and dividing by a random variable, well, wouldn't you believe it, the shape stayed the same. The first one was approximately normal. The second one was approximately normal. And since I multiplied by 150, what I needed to do for center and spread, and actually any locations, is I can just multiply and divide by that constant number, by that 150. You'll notice that that's the same as what we saw on the last page for just any data points. It holds true for a probability distribution as well. So let's see if the same thing holds true when we add or subtract. So Pete is going to, it costs him $100 per trip to get all of the items that he needs. And so you can see how I calculated his profit. There's my probability distribution. Please find for me the new mean and the new standard deviation. You'll see that I have my values on there on your screen now. And I did put the units on there, the dollar amount. The shape stayed the same. The spread stayed the same. However, from my center or really any method of location, you need to add or subtract that value. So you'll notice that the mean is just $100 less than it was on the last page. let's put this all together. Now I put linear transformations here. This is really the key takeaway. I would want you to just kind of star the box. I'm going to use my little fun. There we go. Okay, this is really important, and I should have put it in an even more bold box, but I forgot. So what we're going to do is let's just create a rule for all linear transformations. So let's call our old random variable x and our new random variable y. And I'm going to add or subtract by a value of a. I'm going to multiply by a value of b. Remember that random variables always take capital letters. That's why I've made the y and the x so drastically big, because they're capital letters. Now this always follows the order of operations. That is always true, and that has not changed. So when you are calculating your linear transformation, make sure you multiply first and then you add second. Now the shape, that's always the same. The shape is never going to change. To find your new mu of y, right, y is our transformed variable, you're going to take a plus b times the mean of the x distribution. And to find your new standard deviation of y, you're going to take the absolute value of b times the standard deviation of your x distribution. You'll notice that this guy right here is not affected by a. Which is what we said up above in the more previous box. The spread stayed the same. It was not affected when all we did was add or subtract. And a is what we're adding and subtracting by. Okay, and this, if you can remember these formulas here, this will tell you everything that you need for these transformations of random variables. Okay, I want to consider Pete's sister. Pete's sister, her name is Erin, and she lives in a tourist area in the other part. So here she is. She's going to have a very similar business. Please find for me the new mean and the new standard deviation for Erin's distribution here. I have my values for Erin on there, as well as the units. It's this many passengers. So what I want to ask is this next question that's here. And I want to say, if Pete and Erin have their tours on a randomly selected day, how many total passengers are they going to have? And so we are going to call a new distribution t equals x plus y. And then we can answer that second question later. So let's first figure out how many total passengers do they have. And there are two formulas that we can use to find this, to find the mean of the sum of random variables. So now I'm no longer talking about transforming just one random variable. Now I'm talking about taking two random variables that are separate. Pete's business and Erin's business are separate businesses with different probability distributions, and I want to throw them together. And so we're going to use these two formulas here in order to find this. All right, I want x to be equal to the number of passengers that Pete has and y be the number of passengers that Erin has. Those are actually already the values that we've used. And I went ahead and typed in all of the numbers that we're going to need to answer this question, example 26. So we could figure out the total passengers that they're going to have, but actually what I want to know is, now I'm going to take it one step further. I want to find the amount of money that Pete and Erin have collected on a randomly chosen day. So I'm going to define a new random variable, w. W is going to be equal to the total amount collected. But of course, the values that I have for both x and y are the number of passengers that they have. So I am going to have to transform my variables first, and then I can add them together. So w is really equal to 150x plus 175y. So instead of using it in terms of x and y, I'm going to define two new variables. This is just going to make my life a little easier. And since I'm defining these new variables, I do need to write down what I'm defining them to be. So I'm going to make c equal to that first part, 150x, and let's just use g. I'm going to let g equal 150y. So now my new w is really just equal to c plus g, which is what we know how to use from earlier. So the first thing that I need to figure out is my new c value. And I'm going to use my formula from before. I'm going to take 150 times mu of x. And this is similar, well, it's the same as what we did before. We already did this question in one of our previous examples. And then I need to find the mu of g, which I have not done this yet. So this is going to be 115 times mu of y, which this is I'm sorry, not 115, 175. $175 times mu of y is 3.1. I have that value written up above. That would be 542.50. So to find my new mu of w, I'm going to take the mu of c plus g, which is equal to the mu of c plus mu of g, and that's equal to $11.05. That's how much, on average, I would expect both Pete and Aaron to make on any given day. So let's say they're trying to raise money for a trip. I would expect them, on average and in the long run, to earn $11.05. Let's find the standard deviation. So let's find the standard deviation of C and the standard deviation of G first. I can't right away calculate the standard deviation of W. I need to first find the variance of W, sigma squared. So I'm going to square C plus G. So, whoops. I'm going to take C squared plus G squared. This is equal to 53,954.07. And then I'm going to take the square root of that. And that would be the standard deviation of W, W being the total amount of money that Pete and Aaron collect together. I would like you to consider this and look at example 27. So again, I'm looking at my roulette betting question that we've talked about a few times. And the question that I would like for you to answer for me is, what's better, 2 separate $1 bets or a single $2 bet? And I will let you consider this and kind of think about it. This is going to be your bell work when you get to class. So just think about this question and we will talk about it. And I'll ask you for your opinions when you get to class. Okay. Let's look at the difference of random variables. You can't subtract variances. The variance is always going to grow when you're throwing random variables together. We saw this back with our transformations that we did a few units ago. So there's the two formulas for the difference of random variables. I would like for you to consider one last thing today. I used a Fathom software to simulate taking independent simple random samples of 1,000 observations from these two normally distributed random variables. Okay. So what I would like us to consider is the sum and the difference of the two random variables. And more specifically, I would like for us to consider their shape. That's all I want us to consider today. So please take a look at these graphs. Tell me the shape of X, the shape of Y, the shape of the sum, and the shape of the difference. And they look to me approximately normal. And actually, we are told that X and Y are both truly normal. And I will tell you that the sum and the difference are both normal. I don't need to even use the word approximately. So what's really good news for you is that if we have any independent normal random variables, their sum or difference is also going to be normal. Yay! We love it when things are normal.